Welcome to this video. Yeah, as promised earlier, I said I'm going to take some examples on the bonding and structure of carbonyl compound, and this is it. Now, don't mind the way I construct the question. The main thing is for you to understand what I'm trying to say. I want to pass a message, and I want you to understand. So please get your chair, prepare, and actually get something from this example. Now, these are 7 questions that can be asked of you using one compound. Alkana or alkano or any carbonyl compounds. Now, let's take example 1. They said, answer the 7 questions displayed at the left side, these questions, of the board using acetone. Now, do you believe with me that all these organic compounds we are learning, methane, butane, all of them, we are naming them according to their homologous name, the name they get from their groups. They have their old names. So by now you must be able to be familiar with some old names of some compound in carbonyl groups. Like now, methanol can also be called formalin or formaldehyde, while propanol is also known as acetone, while ethanol is known as acetaldehyde. So you must know all these names so as you help. Now, for a lay person, for someone that is naive, for someone that has no knowledge of this, because of this acetone, even though the person have the idea of solving this question, the person has gone. So as lose the mark. Acetone means propanol. So you must be able to know the structure of propanol. Propanol is an alkanone. An alkanone, the oxygen that is bonding double is at the middle. And propanol is 3 carbon. So draw your 3 carbon. So since the oxygen of alkanone must be at the middle, I can't put it here. I have to put it here. So if you put it here, always show the lone pair of oxygen. That's why it's important, because here now they are asking you 7 questions that is giving you all the details of this compound. So lone pair cannot be neglected. Now why is it that all these other guys are not giving lone pair? Carbon. In my last video, which I talk about the part 1 of this one, bonding and structure, I discuss on, I can show you different the carbon, hydrogen, and oxygen, how they are bonding. So carbon and hydrogen does not have lone pair. That's why none of this carbon will have lone pair. When you are drawing oxygen, don't forget to put your 2 lone pair. 1 here and here. Just make sure you put that every side. Just make sure there are 2. These are lone pairs. Now, each carbon lies on 4 bonds. So if I'm going to complete this bond, this carbon at the middle has gotten 4. 1, 2, 3, 4. So that's okay. So put 3 here and put 3 here. And that's why the molecular formula of this is C3H6O. Good. Now, this is the structure of what we are trying to do. And they asked us all these 7 questions. On this, how do you answer? It's very, very simple. So go with me. The first question said, what is the total number of bonds in this compounds? Bond means the relationship between 2 or more elements here. So definitely, this anywhere you see line, they are bond. For this hydrogen 2, this is a condensed formula. I'm not sure that they are bonded to this carbon, but each of them are bonded to this carbon. So count the number of hydrogen and see they are bonded. This 3 bond, plus this one 4, plus this one here 5, plus this other one 6, plus this one 7, plus this 3 hydrogen, they also bond 2. That's what? This is 3, 4, 4 plus 2, this 2 bond there, 2 bond, that's 6, 7, then plus this one, that's 10. There's 10 total number of bond. Then total number of electrons. How many electrons we count here? We counted 10. So anything bonding is a shared electrons. You have shared it. So this total number of bond is the total number of electrons shared. Now they now ask you what's the total number of electrons. They are not telling you just the bond alone, even the one that does not bond. So already we count 10 bond. So 10 times 2 times 20. But there's about 4 electrons here that is not even doing anything. 1, 2, 3, 4, which we call lone pair. So that 4 plus your 20, that will give you 24. Each bond represents 2. 10 times, because we have 10 bond, 10 times 2, 20. But there are 1, 2, 3, 4 lone pair of electrons that we call lone pair that are not bonded to. So count them together as electron. 4 plus that's 20, that's 24. We get I get that one. And this one, total number of shared electrons. Shared electrons are the electron involved in bonding. So if you have 10 number of bond, that means 10 number of shared electrons will be 10 times 2. Because for us to have bonding, that means we share it with someone. So that's 20. So this extra 4 in the total number of electrons is because of these 4 lone electrons. The electrons that form lone pair, they are 4 in number. Total number of unshared electrons, the electrons that we did not share, and that's the lone pairs. But did not ask you that total number of paired unshared electrons is not in pair. So count this one by one. 1, 2, 3, 4. 4. That means if you want to get the total number of electrons, is the summation of total number of shared electrons plus total number of unshared electrons. So in this molecule of propanol, we did not share 4 and we shared 20. So 20 plus 4 will give you total number of electrons in the molecule. You get it? Now, total number of unshared pair. Now, they want you to rewrite this one in pairs. Count it in pair. So if you count 4 in pair, that means divide 4 by 2. That's 2. Pair means 2. Count it in 2, 2. So there is 1 pair, there's 1 pair, there's 2. So this 1, this 2. So count it in pair. That's 2 number pair of unshared electrons. It's just another form of writing this one. But in pairs, this one does not have pair. Take note of it. 1 pair. And this one, total number of sigma bond. In every single bond, there is always going to be a sigma bond. And in a double bond, there will be 1 sigma, 1 pi. In all the molecules, just always keep it in mind. Double bond can only occur because this one can this one. I just try to put it there. Now, in all the bond of alkanol or carbonyl compounds, it's only oxygen that will always bond double. So that means you cannot expect pi from any bond until you get to that place of oxygen. So now, if I have 3 here, 4, 5 plus this one plus the total bond there is 10. So the number of sigma bond in this molecule, the total bond in this thing is 10. But you know, part of the 10 we have double somewhere. So out of that double, 1 is not sigma, 1 is pi. So remove 1 from that 10. Because when I'm counting 10, this 3, 4, 5, 5 plus this one 8 plus this 2, that's why it's 10 bond that we counted here. But one of these single, whenever you have double bond, whenever you have double bond, one of these double bond is not a sigma. So remove 1 out of the 10. So you have 9 sigma bond. 9 sigma bond, and it now be, this is bond. Bond means 2 electrons. So it now be 18 sigma electrons. But we are not asked that one here. Sigma bond is 9. And that one that you remove out of the 10 bond will now be the pi. Now, if you want to get the total number of bond, you have to add the number of sigma bond with pi bond. Pi bond is not a regular bond, it's not common, it's always scarce. So you can only see it occasionally, so it's not this much. The number is always minimal. So in this whole molecule, you only have 1 pi bond. If you add the pi bond with the sigma bond, you get the total number of bond. And out of all the bond I counted, 1 will be pi, while the remaining 1 will be what? Sigma. Thanks for watching this video. If you really like this video, please comment in the comment section. This is a growing YouTube channel.